So let's look further into the example. Um, the estimates of the betas, that machinery I was talking about that XLMiner does, it's really this iterative process called maximum likelihood estimation. Now, in this course, we won't go into the details of maximum likelihood estimation. There are actually entire courses in this university, in any major university, on MLE. And if you're interested in statistics, you would take a course like that. Now, if we were to include all 12 predictors in the model, the XLMiner's output gives coefficients for the logit. It also gives us the odds for individual terms. So the output looks a lot like the output of a multiple linear regression, except that the interpretation of these coefficients are different because the model is different than how you would have interpreted a multiple linear regression model. This is essentially still a nonlinear model when you're interpreting these coefficients, and let's discuss that. So if we put this into the logit equation, these coefficients just come from this table. So for age, the coefficient is negative 0.045, and we see that coefficient here. For experience, we see 0.057, rounded up, of course, and we see that here. So that is a logit equation. And to convert that into odds, that's just take the exponent value, and you will see you could convert that easily into this equation here. And then you could convert that to a probability is nothing other than the odds over 1 plus the odds. So for predictive classification, we typically use a probability with a cutoff value. In explanatory modeling, we're really more concerned with interpreting the coefficients, and odds have a useful interpretation. The interpretation is that if we, for instance, let's consider beta 1. If we increase x1 by 1 unit, holding these other values constant, then beta 1 is a factor by which the odds belonging to some class 1 increases. So you will actually do a lab exercise that elaborates on this. So the idea is if x1 increases 1 unit, everything else stays the same. Beta 1 is a factor by which the odds belonging to class 1 increases. Therefore, let's suppose that beta 1 was estimated to be 2. If x1 increases by 1 unit, the odds would then double if everything else were held the same. We can use the standard chapter 5 methods to assess the performance of a classification algorithm of logistic regression. In this example, we can consider lift. And a lift chart looks like that. If we've seen, we can apply a decile chart and evaluate it that way. We can also do some variable selection, which we discussed at the end of the chapter on linear regression. It's the same thing, the same kind of concept. So let's say we were to start putting multiplicative terms into the model, like income times family, which is something we can do. That can be very useful from a prediction standpoint, but it can also introduce correlated predictors. And we can use automated selection methods like stepwise regression, forward selection, or exhaustive selection to reduce these variables and to reduce the danger of overfitting when we have overly complex models. So the same idea for p-values applies. We can examine the statistical significance of individual coefficients as well, which is useful in explanatory modeling.